4 in your notes, linear functions. Most of this should be a review of what you know about linear functions, but just give us a good base for going on and extending what we know. So let's turn to page 3 and 4. We're going to start on page 4. Make sure that you include your page number and title. And let's start with the definition for a linear function. A linear function is a function where the difference from one output to the next output is always constant. So if that difference is constant, then you know you have a linear function. So some examples are, in this table we have our inputs and our outputs, x and y. To get from 3 to 8, we're adding 5, and 8 to 13, we added 5, and 13 to 18, again we added 5, and 18 to 23, we added 5. So this table is a linear function because our difference column is always constant. And just as a reminder, this delta symbol, let's give ourselves a little thought bubble here. That little delta symbol means difference. Okay, or a second example, in this table we have outputs -7, -4, -1, 2, and 5. So to get from -7 to -4, we add 3. From -4 to -1, again we added 3. -1 to 2, add 3. And 2 to 5, we added 3. So this is another example of a linear function because our difference was constant and that difference was adding 3. So when we have a linear function and we know that because our difference is constant, then we can write an explicit function for that table. So for example, let's look at our first table. To write an explicit function, we are going to use our f of x notation equals mx plus b, which should look really familiar to you, remembering that m is our slope. And in this example, the slope is that difference that is staying the same. That constant difference is always going to be our slope. And our b is the output for our input of 0, which is similar to our recursive function. It's just that starting output. So let's go ahead and do a couple of highlights here to link these things in our notes to our table. So in this example, our slope is our difference. So our difference of 5, or in our second example, our difference of 3, that's going to be our slope. And our output for input of 0, our b value. In our first example, our input of 0 gave us an output of 3, so 3 is going to be that b value. In our second example, for our input of 0, our output was -7, so that will be our b over there, and that gives us everything we need to write these functions. So for example 1, f of x equals, we're going to fill in the m first, which in this example was 5. We don't change the x, we just leave the x the same, plus b, and in this example our b was 3, so we are going to leave that at 3. So for our first table, our explicit function is f of x equals 5x plus 3. In our second table, we're still going to write f of x equals, and then we want our slope, which in this example was 3. We always want the x, so 3x. Our b value is -7, so this time instead of starting with a plus 3, we're going to start with a subtract 7, because this symbol in front of that 7 is the same as the symbol in front of our 7 here. It was +3 here, so we added 3. Here it's -7, so we are subtracting 7. All right, on page 3, you have an assignment to complete. So I want you to make 2 tables that have constant differences and write explicit functions for each. So you get to make up your own tables. They should look similar to this, but not be these 2 examples. They need to be different examples. You should have your input and your output at least from 0 to 4 on both tables for your inputs. So make sure that you go ahead and copy down the directions and then underneath write your 2 examples. And then you'll be done for this evening.